Hello everybody and welcome back. We're now looking at the last question, B3, on our Canadian Intermediate contest. In Figure 1, triangle ABC has points D and E on AB and AC respectively, so that DE is parallel to BC. In this case, triangles ABC and ADE are similar triangles because their corresponding angles are equal. Lines that intersect parallel lines intersect at the same angle is sort of where we're going with that. Okay. Thus, these triangles have the property that, similar triangle properties, so AD over AB is the ratio of corresponding sides is the same. So that's the same as AE over AC and so on. In Figure 2, WXY is a trapezoid with WX parallel to ZY. Also points M and N are on WZ and XY, with MN parallel to WX and ZY. We should get the same sort of, well, not exactly the same ratio sort of relationship, but I mean, having just talked about Figure 1, the first thing I'm thinking of is finish up the triangle with some point, call it A. Actually, they already used A, so I don't know, some point P. And then you can sort of make similarity constructions, I suppose. Anyway, I don't know if we'll need to do that, but that's the first thing that popped into my head there. Okay, so we got three parts here, an A, a B, and a C. A part, suppose that in Figure 1, DE is 6, BC is 10, EC is 3, and AE is X. Determine the value of X. Well, we know the ratio of DE and BC should be the same as AE, which we don't know, and AC, which we aren't given. But we do know EC. So we could say, I'm going to copy the picture just really quickly. So AE is X. We know we got a 3 down here. So what are we told? BD is 6 and AB was 10? Is that what it was? No, BC and DE, my mistake. 10, 6. There we go. Okay, so what could we do? Let's say notice AC is X plus 3, this whole distance here. Now we know that AE over AC is the same as DE over BC. But then, of course, that's X over X plus 3 is the same as 6 over 10. So we could cross multiply, get 10x is equal to 6x plus 3 times 6 is 18. Subtract 6x from both sides, and we will get 4x is equal to 18. X is going to be 9 over 2. Okay? So there we go. I suppose if you wanted to, you could double check that, make sure the ratios work, but I'm satisfied with that. I think that should be good. Is 9 halves the same as 6/10 of 15 halves? Yeah, because 9 is to 6 as 15 is to 10. All right, so okay, good. We've got our answer to the first bit. X is 9 over 2. All right. What else we got? So B part. Suppose that in Figure 2, WX over ZY is 3 to 4. WM over MZ is the same as XN over NY is 2 to 3. Determine the value of the ratio of WX to MN. Okay, let's copy the picture a little bit. So M and N here, it was W, X, Y, and Z. We just quickly double check that before moving on. Now we're not actually given any values here, but that's okay. We are given some ratios. And that might just be enough. So WZ... Oh, I've got it wrong. W is up at the top. W, X, Y, Z. Okay, that could have been bad. Okay, now, WX is to ZY, column 4, so we might say, let WX have length 3A, then ZY is 4A. I don't quite know where I'm going to go with this yet, but this does preserve the ratio. I don't know what A is, but of course I also don't need to know what A is here. And then what was our... We had a 2/3. Two of them were 2/3. WM to MZ and XN to NY. So if I were to let WM equal 2B and XN equal 2C, then MZ is 3B and NY is 3C. So we can put that on our little picture there. 2B, 3B, and then 2C, 3C. And what do we want, though? It's WX over MN. WX to MN. Alright, so what can we do there? Well, actually the first thing that jumps out at me is to extend the triangle. Let's redraw the whole thing. So we got 3A and 4A here. 2B... Oh no, this is 2C, wasn't it? 2C, 3C, 2B, 3B. Okay. So, before we go any further, I think I should probably say, you should, if you're going to create a picture like this, say, let P equal the intersection of the extension of WZ and XY. So just extend them until they meet up here, is the idea. Okay. Now, if I were to call this side something like 3E and 3F, let PW equal 3E, PX equal 3F, then by similar triangles, we see that 3E plus 5B's, so this whole side over here, has got to be equal to 4E. And 3F plus the other side, 5C, has got to be equal to 4F. So, 5B is equal to E, and 5C is equal to F. Okay. Now, incidentally, why is this working? Well, the big red triangle to the small blue triangle, similar triangles based on what they told us about figure 1, but I know the ratio of this side to this side is 4 to 3, so the ratio of the other two blue sides to their corresponding red sides must also be 4 to 3. And if you feel that needs more explanation than just by similar triangles, then by all means add it in. But now I figured out these sides in terms of E and F, well, in terms of B and C, really. So what we've got is we want Mn to Wx. So this is 2b, this is 2c. This is now 15, 3 times 5b, 15b, and 15c. This is still 3a. Okay, but now, by similar triangles again, we can see that MP over WP must be the same as MN over WX. Is that the order we wanted, or is it WX? No, we want WX over MN. Okay, we'll do it the other way. WP over MP has got to be the same as WX over MN. But this one here is 17b over 15b. Nope, wrong order. 15b. I need the smaller one on top. 15b over 17b. And so when everything's said and done, 15 over 17 is this ratio. There we go. Okay, so not too bad. Not too bad. Now we've got C part left to work on. So what have we got in store for C part? Suppose that in figure 2, Wx over Zy is 3 to 4, so exactly the same thing we just had a moment ago. That's fine. And Mz over Wm, so they're flipping this fraction, but these two ratios are still sort of the same. That's good. And that this ratio is equal to a positive integer. So it was 2/3 up here. That's probably why they flipped it. Because ny looks a lot bigger than xn. Okay. So this ratio is equal to a positive integer. If wx plus mn plus zy is 2,541, and the lengths of each of these is an integer, determine all possible lengths of mn. So we are looking for integers. Okay, so what can we do? Well, I feel like, once again, we're probably going to have to dip into the similar triangles by extending this point here. So we can say something like in B, extend x, y, and wz to meet at P. Now, where can we go from there? Well, let's draw a picture here. I think we should probably give a name to this integer that we know about. Wx, y, z, m, n, and p. Let's say let ny over x, or nx equal k, and that's the same as zm over wm, and this is an integer. Okay, I do have the right ratios, correct? Alright, so yes, ny over xn, yeah, sure, they just switched the letters around on me, that's fine. So, oh, I suppose we could also say that this be 3a and this be 4a. Okay. So we can rearrange our ratio here so that ny is equal to k and x So if we call this B and this C, then this is KB. Well, I'll keep the order the way the side the same as we had them before. So we had C over here, this will be KC, and this will be B over here, and this will be KB. Okay. And now, is it as simple as just saying let this be 3E and 3F and going from there? What did we know the sum was? We know the sum is 2,541, and that's ZY, MN, and WX. Okay, we know that they're integers. The only variability we know is sort of this K value here. Yeah, I think if we go ahead and say let WP equal 3E and XP equal 3F. Then 4E is 3E plus B plus KB. And 4F is 3F plus C plus KC. And you probably want to remind them this is by similar triangles. So E is K plus 1B, and F is K plus 1C. Okay, now we should be able to figure out MN from here in terms of... MN is the other one we want. We should be able to get MN in terms of A, I think. If we redraw this, 3A, 4A, this is 3K plus 1B, or C. And over here is 3K plus 1B. This is a single B, this is a single C. WXMN. By similar triangles. MN, we'll put MN on top. MN over WX is the same as PN over PX, which is, so PN would be, add on another C, so it would be 3K plus 4 C's over 3K plus 3 C's. 3K plus 4 over 3K plus 3. So if we want to multiply, so we can cancel out the C's. MN is 3K plus 4 over 3K plus 3 WX. And that needs to be an integer. So WX and MN are integers, as is YZ down there at the bottom. Okay, so this is going to impact our choice of K. Now, do we want to be working in terms of K, A, what have we got here? Oh, WX is 3A, we said. And this is 3K plus 1 on the bottom, so this is 3A. So those will cancel out. We get 3K plus 4 times A all over K plus 1. Okay. So so there's the K here, and then there's the A here as well. First thing I notice is K plus 1 does not It has nothing in common. No factors in common with 3k plus 4. How do I see that? Well, 3k plus 1, if you multiplied it by 3, it would be 3k plus 3. Those differ by 1. Any two numbers that differ by 1, their greatest common divisor is going to be 1. So 3k plus 3 and 3k plus 4 have no factors in common. Well, any factor of 3k plus 3 should still have no factors in common with 3k plus 4. So for mn to be an integer, k plus 1 has to, all of its factors have to be canceled out by factors coming from a. So I guess instead we could say something like let a equal t times k plus 1, where t is an integer. Well, yeah, obviously t has to be an integer. I don't know why I wrote a question mark there. But then wx is 3a, mn is 3k plus 4 a over k plus 1, and zy is 4a. So now this turns into 4 k plus 1 times t. This one up here is 3 k plus 1 times t. And the k plus 1 and the k plus 1 from a cancel out. And so this should just be 3k plus 4 times t. Okay, and now we know the sum of all of these is 2541? 2541, there it is. Okay, so go back there, 2541, and we're going to get a factor of t here. So I'll call this 7k plus 1, just adding the 3's and the 4's, plus 3k plus 4 all times t. We can expand this out, 7k plus 7. This is going to be 10k plus 11 times t. Okay. So now we can start looking at integer factors of 2541. And we want to break them down into two factors. T, we don't really care what it is, it just needs to be an integer. But the other factor needs to look like 10 times something plus 11, and that's how we're going to find our k values. And only so many of those will work. So there's only going to be so many pairs where k and t are integers as needed. And then that'll give us only so many possible values for mn. And we do want the values for mn, not just how many possibilities, right? Determine all possible lengths mn. Okay. So now let's just take a look at the factors of 2541. They add up to 12, so there's a factor of 3 I can get rid of. I'm just going to grab my calculator and make this go faster. So I get 847. That adds up to 19, so there's nothing I can do there. It's not divisible by 5. Let's try divisible by 7. Yep, there it is. 7. Yeah, 121, and of course that's 11 squared. So 2541 is 3 times 7 times 11 squared. Okay, so that's good. There's only going to be 3 times 2. There's only going to be 12 pairs of factors, or 12 factors, so 6 pairs to work with. Let's say we could have 1 and 2541. We could have 3 and 847. We could have 7. I can also have 11. So 7 and 363, I believe. Just quickly double check that. Yeah. Factor of 11 in there. And then the next one would be 21. And then 33. So 33 and 77 should go together. 121 should go with 21. And then 11 and 231, I believe. Okay, so that all works out. Now, which of these are 10 times something plus 11? So they'd have to end in a 1. Well, actually, the 1 can't work at all. So, the only possible candidates are 2541. Make a smaller chart down here. So the t values can be 1. So neither of those will work, neither of those will work, neither of those will work. We can have 1, 11, 21. So 10k plus 11 looks like this. So 10k, and then we can work out k. So subtract 11, 2530. 231, so 220, so k would be 22, k would be 253 here. It looks like all of these should work, so do we get... Oh, 11 probably won't work for my... So with 121, 231, so 10k plus 11 would be the leftover 121, the leftover 21, the 11. Subtracting 11, you'll get 10k is equal to 0, so k would have to be equal to 0, but that's not going to work because then we would get some side lengths that are not actually there. They're degenerate side lengths. They'd be length 0. So that one won't work. So it looks like we'll get 4 different values for k. Each of those should give me a different possible mn. We'll get 110 here. So that'll be 11. Oh, I'm noticing k is always a multiple of 11 there. That's kind of cool. I don't think that'll be the case here. Subtract, you'll get 10. You'll get k is equal to 1. That's fine. And then what do we need? We need mn. What did we say mn was? 4k plus 3k plus 4 times t. Here's my t values, my k values, 3k plus 4, and then mn. It's not liking the top of the screen there. There we go. 21, I can't remember what the other one was, 121. K was 1, 253, 22, and 11, I'm pretty sure. Yep. So 3k plus 4, this will be 7. So 7 times 121. $847. So that's an MN. 11 times 3 is 33, plus 4 is 37. 37 times 21 is 777. 22 times 3 is 66, plus 4 is 70. I'm noticing a lot of 7s here. 70 times 11, it'll be 770. And 253 times 3 plus 4 is 763, times 1 is 763. So these are the 4 values of MN that MN can be. But there we go. Okay, that wasn't too bad. Neither the B or the C part was particularly challenging, as long as we thought to use this point up here, and indeed we did. So there we go. We didn't have to do anything else, right? Determine all possible lengths MN? No. And we did ensure WX and ZY were integers. That wasn't too bad, as long as A was an integer, so A just had to be a multiple of K plus 1. And yeah, everything worked out. So there we go. That finishes off the 2018 Canadian Intermediate paper. If you're looking for something similar but a little harder, try the 2018 Canadian Senior paper. Same layout and structure, but the questions are aimed at a higher math difficulty. If you want to practice other written contests, the Fryer and Galois papers that I go through are aimed at this particular level. They're a little shorter, but you can still practice your writing skills. Whatever you do, I will see you around, and keep on enjoying math.